Let's go deeper into what testing actually is, because the more you look at it, the harder it becomes to describe as a role, a task, or a checklist. Testing is often described as execution. Run this test, verify that behavior, report the result. That description sounds simple, and it's completely misleading. In reality, a tester rarely tests just their component. Even when the responsibility is clearly defined as software level, testing immediately forces you outside that boundary, because nothing exists alone. Let's take a concrete example. Imagine you are responsible for a component in a car that opens the doors when a signal is sent from a phone. From the outside, the behavior is simple. You press a button, the door opens. But to test your component, you need to understand everything that makes that moment possible. Before your component even does anything, the ECU needs to be able to receive messages. That already means another component allows communication. Specific certifications are present. The system has connectivity. The message can be decrypted. The message is validated as trusted. Only after all of that does your component see the signal. And even then, your component usually doesn't open the door. It sends another signal. That signal goes to another ECU. That ECU controls the actuator. That actuator opens the door. So when the door doesn't open, the problem space is large. It could be your logic, the communication layer, authentication, configuration, timing, another ECU, the environment itself. To test properly, you need to understand this entire chain, not to implement it, not to own it, but to know where reality can break. That kind of understanding is required even at software test level, and to gain it, testers are expected to navigate a complex tooling landscape. In automotive alone, this can include CANNU or Canalizer for communication analysis, Jira for issue tracking, Confluence for documentation, Doors for requirements, internal flashing tools, cloud platforms for back-end messaging, measurement tools for currents or signals, logging and tracing systems across ECUs. None of these tools exist in isolation. They interact, and a tester is often expected to understand all of them well enough to determine whether something is broken and where. Now compare this with software development. A developer's work is complex. They need to code, understand architecture, and reason deeply. That is not easy, but it is visible. People understand what a developer does. They write code, they commit changes, they build features. The output is concrete. Testing is different. A tester's work often starts when something doesn't make sense. The system behaves inconsistently. The environment acts differently today than yesterday. A test passes once and fails the next time, and sometimes there is no clear explanation. Now take a web example. You test a feature that depends on an API hosted in the cloud. A request fails. To understand why, you may need API gateways, authentication systems, cloud logs, environment configurations, feature flags, deployment versions, messaging queues, timeouts, and downstream dependencies. You may look at application logs, infrastructure logs, cloud dashboards, monitoring tools, tracing systems, and still nothing is obvious. At that point, testing stops being execution entirely. It becomes investigation, and investigation doesn't fit well into reports. Sometimes the issue isn't even in the product, it's in the environment. A service was restarted, a cache behaved unexpectedly, a local setup is inconsistent. Sometimes you lose hours, and after a random restart, the problem disappears. No code change, no configuration change, no explanation. How do you document that? You can't. And if you try, the documentation takes longer than the problem itself. So, testers do what they often have to do. They put their head down, they reset, they try again, and they move on. From the outside, it looks like nothing happened. From the inside, it was real work. This is why testing time is so hard to log. Not because testers are inefficient, but because a lot of testing work is non-linear, exploratory, reactive, based on pattern recognition, based on experience. You can't document every thought, you can't predict every investigation, and you can't always explain why something felt wrong, only that it did. Yet, when a ticket is finally raised, a good tester already has an idea where the problem likely is, not with certainty, but with informed intuition. That intuition is built from understanding systems, not executing steps. This is also why "it's not working" is never a good test result. A tester's value is not in stating failure, it's in narrowing the space of uncertainty. Testing was never meant to be a task list. It was meant to be a way of seeing systems under real conditions, across tools, across components, across environments. When testing works, nothing happens, and that's exactly why it's so easy to underestimate.